Hello dear students, I am happy to meet you in the second lecture, the first week. Here we are going to talk about two things, exponent and radical. When I say exponent, I mean the power, x to power something, for example 2 to power 5, here's the number with the exponent 5. And also radical, we mean the roots, for example we have square root of 8. So in this video I am going to clarify both concepts, exponent and radical, for you. The first concept is exponent, and we have integer exponent. Integer, you know what I mean by integer in the 1.1 video, in the previous video. We said that we have a integer and rational. So if I have 2 with 5 and this number is integer, belongs to the z or integer numbers, we say it's an integer exponent. In the second part, we will talk about the rational exponent. Okay, rational. When I say rational exponent, means that, for example, 2 to power 1 over 3. The exponent is rational, belongs to q. Okay, rational exponent. That's all. So before we start, you should know, or we should know our outline, our objects for today. Now we are going to talk about the part A, with the integer exponent. When I say integer exponent, for example, I have something with n, where n belongs to z, to the integer number. Now here I have what? I have 1 over 2. Okay, in the example 1, page 11. Example 1 in the first page, page 11. Okay, here's page 11. We have what? Example 1, A. We have 1 over 2 with exponent 5. Here's the x with 5, okay, with the integer 5. So it means that 1 over 2 multiply, 1 over 2 multiply, and go on. 5 times multiply 1 over 2, and you get what? You get 1 over 2, 32. Why? Because 2 to power 5 is equal to 32, that's why. So how about B, example 1, part B? We have minus 3 with the fourth exponent, so we know is equal to, means that we have 4 times multiplication 3, 3, minus 3, minus 3. And you know, if we have an even exponent, or so negative will be disappear, okay, will be missed, will be eliminated. We eliminate negative sign because we have what? We have even exponent. Even means that like 2 even numbers, like 2, 4, 6, 8, and go on. Okay, so in that case we will eliminate negative, and we say is equal to 3 to power 5 to 4, sorry, which is equal to 81. Okay, dear. So how about part C? Look, we have minus 3 to power 5. What's the difference between example or the part B and branch B and C? Here's the exponent just for the 3, so we don't eliminate, it's outside, so we don't eliminate the negative, so the negative remains, and we have minus 81. That's why. Don't say the lecturer or the instructor, the teacher, say that we should eliminate negative. Yes, you are right, but if it's inside the bracket, but here is outside bracket, so that's why the negative not eliminated, it just remains like that. You will put it here. So in your lecture note, look, you say try to solve example 15. This is very important. Please, after you are studying this video or are watching this video, when you finish example 1, go directly to the example 15 and try to solve it, because really it's related to this part, and it's very important for your homework, assignments, quizzes, reports, final reports. So that's why it's very, very important for you. In your example, you will face example like number 15 or like example 1. So that's why I say after each section or each example, he recommended you, or it recommended you to try to solve this one. So do not forget about that. Okay, dear? That's all that I want to mention in the first page, or page 11. We are going to page 12. It's also related to the integer exponent, but now you know the integers are negatives. For example, you have a lot of numbers, negative 2, negative 1, 0, 1, 2, and go on. Now we deal with the positive part. Now it's time to, in the page 12, to deal with the zero exponent and negative. Okay, so how we deal with the zero exponent? We have two rules here. And any numbers, I don't say every numbers, I say any numbers with the zero exponent is equal to 1. So when I say any numbers, means that 1, 2, 3, 4, any numbers. Okay, so example 2 in page 12, we can deal with any numbers 7 over 4, or sorry, 4 over 7 to power 0, or any other numbers. It depends, is equal to 1. Now I'll give you an example. For example, 2 to power 0 also equal to 1. For example, 10 to power 0 equal to 1. Any numbers negative to power 0 is also equal to 1. Okay, dears? So after these, you know the zero exponent give us what? The outcome of the zero exponent is 1. Nothing else. Okay, dear? Now, how about the other part? Negative part. For example, he say that a minus n means that any numbers with the negative exponent is equal to 1 over a. So we will take it a reciprocal, algarawa. Okay, 1 over n, reciprocal. So how we get this? How we deal with this one? I'll give you example. If I say 2 to power minus 1, so means that 1 over 2. Okay. When I say another example, when I say 5 with the minus 3, means that 1 over 5 to power 3 was equal to 1 over 125. Okay, dear? So when I say another example, 2 to power minus 3 means that 1 over 2 to power 3 was equal 1 over 8. So that's all that we have. It's very, very important because you have a lot of example and you should deal with it. Okay, now I'm going to clarify the example 2 in your page 12, part C. We have what? Example 2 again, part A. Now I'm going to talk about part C. We have what? We have minus 2 to power minus 3. So, as I will say directly, minus 2 to power 3. And you know, it's odd exponent, is not even. So the minus will remains. Now 2 to power 3 is equal to 8. That's all that you have. Okay. If you have any question, you can also, I will remember you to ask me during your Zoom meeting that we have in each class we have it. So it's very important to try to solve this one. How about B? Look at the B. We have just x. Okay, we have x. So we say x is equal negative x. We say is equal to 1 over x. That's all. And you can write x to power 1, but it's not nice, you know, because we are in the math. We don't write 1 really. That's why directly we pass this step and we say we have a 1 over x. So the very the important thing is how to deal with this one. You can see in here, in that properties, we will use those trick in the example 2, or maybe later we will find all the negative exponent and how to deal with it. That's here. You can see it in the other page. Okay, in the page 13. So just be patient. I will teach you, or I will give you the reason why we teach you this exponent and what's the benefit of this rule. Now I'm going to give you many important things here. Really, we will use these law in the page 12 and 2 more additional in the page 13. From here till the last lecture in this semester. So please, and please, again please, pay attention with me and do not skip these rules, because really we will use it many times. So if you control them, you will find, or you will see, it's many other exams are easier for you because you can do it by yourself. Okay, now the page 12, we have 3 laws. Really, I don't memorize these rules. I just use them. I don't want to say it's a first rule or second rule. No, it's not important. First or the second. The important things here is to know how to use it. You know how to use these examples. That's all that I wanted from you in this lecture. First of all, the first laws in page 12 from 1 to 5. Okay, so the first one is what? As if I have am, here's the a is a mentioning for any number, m is any exponent, multiply to another number but with the same base. So in the exponent we have a base and exponent. Okay, here's base, here's exponent, n or m, any other symbol that we will use. Okay, so am means that number with the exponent, with the an means that the same number with the different exponent. So if we have a multiplication, we say is equal to a, because the base are equal, so we say, and we will add or sum the exponent. So in that case, for example, if you have 3 to power 2 multiply 3 to power 5, we say that depending on this rule, because the base are equal, so we say it's equal to 3, 2 plus 5, which is equal to 3 to power 7. That's all that you have. I'll change this one to another language, which is in your example 3 part A. So I say x to power 7. So from the number language to the variable language, and we say is equal to x to power, because both of them, they are x and they are same base. So we say is equal to 4 plus what? 4 plus 7, which is equal to x to power 11, and that's all that we have. Okay, dear. Now for the second rule, we have what? We have am over an is equal to am minus n. Again, if you have, instead of multiplication, you have the division in the two numbers. Okay, if you have a division between two numbers, two exponent numbers, or expressions, but with a different exponent. So directly I say this one is going to up and it will be minus. Like example, if I have 3 to power 2 or 5, maybe 5 here, and 3 to power 2, directly I will say what is equal to 3, 5 minus 2. Okay, dear. So in that case you will have 3 to 3. How about if I change this one? For example, I say 3 to power 2, 3 to power 5. Now it's okay, the same, but here I say 2, do not forget, 2 minus 5. So that's all that we have, and is equal to minus 3. And you know how to deal with this one. That's all we need. Okay, dear. That's all we needed in the example. Now again, we will change the number language to the example that with the variable language, c or x, let be x, and 9 x to power 5. I will say, because I have x, and here there's a division by the second rule or any law that we don't need to mention, just use it. I say is equal to x to power 4. That's all what I have, and you can see example 3 in your page 12 part C. Okay, now the third rule, which is very important also. If I have AMN, I will say is equal to AMN. What do you mean by that? It means that if I have one variable, one base with the two exponent, we don't add them, we don't do anything, just we say that the result is equal to the base the same, and we multiply the exponent. I'll give you an example which is more easier for you. If I have 3 to power 2 5, directly I say is equal to 3 2 by 5 multiply, which is equal to 3 to power 10. Okay dear. How about if I will change it to the 3x to power 3? So another example, as I told you in the variable language, I say is equal to, okay, is equal to 3, sorry, not this example, I will say is equal to 4, okay, x to power 4, 3, so I say is equal to x, 4 by 3, which is equal to 3 by multiply by 4 is equal to x to power 12. That's all we have. So more important things here, this rule ABC is 1 2 3 that I mentioned for you. Now we are going to finish our two examples. Here we have number 4. We say is ABN, okay, is equal to ANBN. Here's your rule number 4. What do you mean by that? For example, if I have 3 multiplied by 4, all of them to power 2, you can do this by 2 steps. You can directly multiply them, you see 12 to power 2, or is equal to 144, or you can say what is equal to, depending on this rule, 3 to power 2, separate them, multiply 4 to power 2, is equal to 9, multiply 16 is equal to 144 again. Okay dear. So it depends on the students how to deal with. The rule says this is the standard way, and you may do it by that, like that. So okay, it depends on the student, it depends on your way or your method. All of them, they are right. Now I'm changing this one to the mathematics or variables language. If I have something like that, I will say is equal to 3.2 x to power 2 is equal to 9x squared. That's my result. Okay dear, that's all that I wanted from you to learn in this page. Number 5, law number 5, we have ANB and is equal to ANBN. Okay, what do you mean by that? For example, if I have 3 over 4, all of them to power 2, I see is equal to 3 to power 2, 4 to power 2, which is equal to 9 over 16, and you can do anything that if they have that common. How about another language? If I have x to power 2, all of them power 3, I will directly say is equal to x to power 3, 2 to power 3, which is equal to x cube. We say cube. For the square, if it's at power 2, we say square, otherwise we say cube. So now I have x cube over 2 to power 2 is equal to, 3, which is equal to 8. That's all we have. Okay, now I applied this rule on this example as I mentioned for you. I see that they are the mathematics language. Look at the number B, for example. I have what? I have y to power 4, y to power minus 7. So how we deal with this one? That's the application that I say. Do not memorize the rules, just try to apply them. But how we apply them in this example, I say we have one AA, we have one similar base or one base, so I have a similar base. Now we have multiplication here, so I'll say directly, I say the Benchine to Ankoki, now the base are equal, so we add the exponent, and I will get what? I will get minus 3, which is equal to 1 over 3. I have a note for you, so please in the exponent or in any mathematics expression, shortly as I write mathematics expression, we need single positive exponent. When I say we need single positive exponent, I mean that if you have something like that, this is one base, unique base, single base means that one base. Okay, I agree with you. When I say positive exponent, the exponent should be positive like that. So you, in the exam or in the quiz, do not ask me about shall we leave it here or there. No, leave it here. Why? Because I do not leave it there. Why? Because this is not it's not a positive exponent. Okay, dear. So each exponent, or a to power n, it should be, this one be single. I don't need to have two base. I want to just single base, and n should be positive. I don't want to leave it to me as a negative part. Okay, أبيت همیشه بنشینه یک دانه هبه تو أنا كشي موجبه. Okay, now we are going to page 13. With the important for you, I'm going to solve one of them, and I'll leave the second for you. Choose the first or the second. As usual in the offline lecture, offline class, usually the students say part B because they so it's more difficult. So that's why I'm going to solve part B for you, and I'll leave this one for you as a homework. Do it by yourself, okay? And later try to solve 43 and 47, because this is your question in the quiz or the exam or the any other assessment like a homework or assignments. Okay, now here we are starting by solving the B for you. So example 4, page 13, part B. Okay, say x over y over 3 to power 3, and here we have 4 x square y z. Okay, here's your question. Okay, dear, so this is example 4, page 13, number part B. I'm going to solve this one for you. And you know, this is by this rule. I will write the rule for you, but you don't do it in your exam. Just try to solve for me. We have AB over n, we say is equal to AN BN. So by this step, I say is equal. Do not forget to write down like that. Equal. Okay, this one equal to what? X to power 3, y to power 3. By which rule? Tell me. I don't memorize it, but I know this by this rule. Number 5, fifth rule. Okay, again. So I have 4, so I say y square 4, x to power 4, z with the exponent 4. This is also again by what? By fifth one. Now, this one is equal to what? I see is equal to x cubed y3. And this one, by which rule we should multiply or add? Which is equal to 2 multiply 4. By which one? Really, I don't memorize it, but you can check or review it by the third rule. So by the third rule, say if you have the brackets, if you have something like that, we should multiply it. Okay, so we will remove the parentheses, and we will multiply the exponent, and this is nothing to do it, and this is nothing to mention. Now as I told you, I want a single positive exponent. So what do you mean by single positive? Now I have how many bases? I should just remain 1x, 1y, 1z or z. No more else. Now I have 2x, 2y. So how we deal with this one, I'll tell you. So it's x to power 4, x to power 5. We arrange it. We will order. Okay. Now y to power 8 over y to power 3, z to power 4. Okay. Now the numerator is equal to what? Is equal to xx. So by the first rule, we have a same base. So we will add the exponent, And now this one is y to power 8. This one, by the second rule, is going to be like that. And here's the z, it remains. I will not change the z because z is what is positive exponent, so I'm not going to bring it up to numerator and be minus 4. That's why I will leave it here, because I want a positive exponent. So is equal to x to power 7, y to power 5, z to power 4. That's all your answer, and you can check in your paper how's the example and how you get this one. So try to also, you have a solution of A, so please try to do it by yourself without watching the answer. Try to see the answer later when you finished or when you solve it by yourself. Now again, as I told you in the page 13, it's very important to two more properties here is with the minus and with the minus. So how we deal with that one? Now, in this example, we have a big parenthesis. Okay, we have a big parenthesis. The sixth law, we have a over b. So you have a fraction, as I told you, fraction كرت with a big parenthesis كوانيش يقولها minus n, any number. So he say that you can deal with this one as a b a n. So try to upside down them, reciprocal them, change it, swap them between up and down. So is equal to what? Is equal to b over n. And do not forget to change. Do not forget to change the denominator to numerator and the numerator to denominator. You should swap them, upside down them. So this one is called the racing fraction with a negative power into and invert into the positive fraction. That's all that we have. Example on this one, if I have 2, 3 with negative 4, I'll say is equal to 3 over 2, all of them with the 4, I change it, and it's equal to 3 to power 4, 2 to power 4, and go on. How about the example or mathematics language with it? So in case I have y to z to power 3 with minus 2, I'll say is equal to, I'll change them. I say is equal to what? 2z to power 3 with 2 and y, right? So you will change them. Sorry, I made a mistake. So now is equal to what? By the first law or the third law, we have 2 to power 2 and z to power 3 to power 2 and also y to power 2 was equal to 4z to power, by third one, 6y squared. Now I have a positive single exponent which is equal to this result. Okay, dear. So maybe you ask, or you have a question in your head. You say, if I don't try to give almost detail, if you are doing correctly, it's okay, do it. You can pass from here, but it's better for me if in case I want to result, it's okay. Otherwise, if I want a step or in your report, please try to do your step, because the step is very important. You will not grading on the result. That's it. So how about the next example, or the next law number 7. If I have a minus n and b minus m, directly change to bm, so it means that this one going to up and this one going to down n. So this is very important. I am going to simplify this rule for you. If you have something like that, directly you can say that as we mentioned in the negative exponent. If you have part b, if you have 1b minus here, so if you have a negative exponent in the denominator, you can raise up to here. Okay, that's all. So minus b is going to here will be b, minus n going to down will be an. Okay, dear. So that's all that we have. Now I will solve another example for you. If I have 6s t minus 4 over 2s minus 2 t to power 2, so is equal to what? So before you starting, you have two numbers, so they can you can find the factor. So I say by over 3 I will over 2 I will get 3, over 2 I will get 1, so it remains 3. So 6 divided by 2 is equal to 3, as you know. Okay. Now about s and s negative, look, it's like a number 7, rule number 7, or the 7th law. So I see is equal to s, this one should become to up. So usually the smallest should go to the biggest. So now between 1 and minus 2, which of them is smallest? Surely minus 2. So the negative should become to up. So I have s to power 1, and here should be s to power 2. Okay, dear? Because by the 7th rule or law is going to up. Minus b going to up to will be bm. Okay? Now, between t, I have a t, minus 4 and 2. So which of them should be go to the other? Which of them is the largest one? 2. So it will, we will fix this one, and we will change, or we will remove this one to down. So I'll get what? I'll get t to power 2 and negative 4, because the smallest exponent should come to down, and we'll get the 2t power 4. Now later, in the last step, I get what? Because depending on the first rule, I'll get this. Depending on the first rule, I'll get this one. I solved the example 5 in your page 13. This is the part B. Example 5 in your page 13. This is the part B. And previously, I solved it for you. This part is what is example 5, page 13, part B, A. Okay? So this is the part A. I solved this one for you. Why didn't I mention that? Because I want to teach you to how to, without memorizing, how to use these properties. That's really very important for us. Now, page 14 in your lecture note, we have another example. No, we are going to deal with a radical. When I say radical, you should memorize two things. Root, when I say root, square root, cubic root, fourth root, fifth root, anything. And also the translation of root. What do you mean by translation of root? I mean, for example, if I have an x, I see x to power 1 over 2. With what? With the exponent with the rational exponent. Okay? So, we will combine this one later with the part B. So do not forget about this. Okay? Because in the exam, or in the when you study, it's better for you to combine, to collect all subjects that you have without memorizing them. That's why the students they don't like the math, because they cannot connect all of them together. They just see the radical as a separated part. They will study this one as a separated part. In really, all of them exponent, they are the same. Now I'm helping you for that. Okay. Here what we have. In the radical, say that in the definition, of course, we have two things, N, A, B. We recall this one as a base for, or as a root, and we have the roots, the degree of the root here. Okay. For example, if you have 41 is equal to 4. So how to find this one? Is equal to what? Without using calculator. Of course, I know you see why we don't use the calculator, because you don't know how to use the calculator. Okay, that's why I say don't use the calculator. In case you can use it, okay, do it directly, because really we are in the online class, so you can do it at home. But I'll teach you, or I'll let you know, how about the result? You know, you just do it by like that without knowing what happened in your small intelligence calculator. What's happened? The small smart things. What's happened? Now we have 81. We will use the factor. We'll recall this one factor. Factoring number. What do you mean by factor? In Kurdish we say shital. So factor, we say that we will divide this one to what number that we want. Because this is the even odd, we will choose the 3. If it's even, try to choose the 2. If it's a 0, try to choose 2 or 5. So if you have a digit here is odd. When I say odd, it means that 3, 1, 5. Try to use 3. If here's even, last digit. When I say last digit, I mean here 1. It's the first digit, the second digit. If you have a lot of numbers, okay, use 2. If there's a 0, you have two options, 2 or 5. Okay, that's all. So I have a 81. 81 is the odd, so I can divide. So 81 by 3. 81 by 3. So we see is equal to 3. We have a 2 and 6. 27. It remains. Okay. So 27 multiply 3, you get 81. Or 81 divide by 3, you will get 27. Now, 27 also again is odd, the last digit, so I'll say divide by 3. So 27 divided by 3 is equal to 9, and you know 9 divided by 3 is equal to 3, and 3 divided by 3 is equal to 1. So we have what? We have 1, 2, 3, 4 digits. All of them, they are 4. Now I have what? I have 4th root, means that I need 4th root. This is root 1, root 2, root 3, root 4. So if I say 4th root, I will choose just 1 because you have a 4th root. So 1, 2, 3, 4 is equal to just 1. So I will say is equal to 3. My question for you, with using the calculator, please find this one for me. Is equal to what? Now I'm doing by my work by factor. This way I see by 3, I get 2000, 3, 9, 3, 3, 3, 1. So because I have the 3rd root, means that I will choose or I will select 3 numbers. So it remains what? Just 1, 3. How about this one? So I see is equal to 3. Here's cubic 3. This is the remainder, I'll put it here. Okay. That's all that you, without using the calculator, you are faster if you know how to do it. Otherwise, or you at least you know how to write this one, or this one is equal to what. Forget about that. Now we have also cubic root of minus 3, as you know, is equal to, because we have a cubic, the negative will remain. If we have a even root, you know the negative shouldn't be here because we have it's undefined. So for that I say is equal to 2, because 2 to power 3 is equal to 8, minus 2 is equal to minus 3, 8. That's why. How about 14, 16, and try to solve, review this information for you. Now there's nothing I'm going to. Now in page 15 you have a property of this again. These properties is also look like the other properties that we taught you, or you saw it before for the exponent. Now the first property of radical property, you have the first one, a b n is equal to what? Oh, really I forgot to tell you about something else. Tell me what we haven't here. We have this one and that one. Just tell me from 1 to 7 what we haven't. In the Zoom, answer me, you will get your grade. 1 grade. What we haven't. Also here I have the same question. What we haven't in this rule. We have all these rules, but we haven't. We will discuss this one in the Zoom when we meet each other. So that's why I say this is important rule. So be with me and look at them. Now, the first rule, we have multiplication between AB and with the same exponent, we will say we will distribute as a an bn. What do you mean by that? For example, if you have 3 minus 8 multiply 27, you can multiply them, or you can, if you see it's easier, you can do it by here. Why you don't multiply? Because directly I know this one is equal to minus 2 and this one is equal to 3. That's why I say is equal to minus 6 is easier. That's why we separate them by this rule, first rule. In the math expression, in case example, if you have, for example, 81 x to power 8 y to power 4, so this is the example 8 in your page 15, example 8 in page 15, part B. So if you have something like that with the 4, so is equal to what? I will say is equal to 81 to power 4 and x to power 8 with a 4 and y to power 4 with a 4. Okay, and later we will solve this one, just as for more using the first law. In the second law, in the exponent, if you have fraction with nth, we can distribute the nth root over the fraction. So we say that is equal to what? Example, or if I give you example, if you have 1681 over 4, so is equal to 416 481, and you know is equal to 2 over 3. Okay, we solved this one before.